Well, so we'll start today something new, that is rotational model. So only there are few topics left. You have a rotational model, this is a part of collective model. Then you have a neutron problem. And next, and that is last, that is your nuclear detector and nuclear reactor. So within, I think, 4 classes will going to end up all these things. In rotational model, experimentally it is observed that the nuclei having mass number in between 150 to 200, and also when that mass number greater than 230, with even combination with Z and N, that is basically even combination.
So
Yes,
this model is different from shell model, or it is
exactly different from cell model.
okay, sir.
We are going to discuss, then it will be clear.
Okay.
So that you have a rotational model, that I mean this model is actually observable for the nuclei having mass number in between 150 to 200 or mass number greater than 230 with even combination. For this type of nuclei, from here you can see now the nuclei having large size, mass number 150 to 200, that is also this is large, right? It means this nuclei is having large size, and also this nuclei with even combination. For this for such type of nuclei, it is experimentally observed that there are levels. There are levels with even spin. With even means spin means 0, 2, 4, 6, and so on. With even parity. These are the level that is exist for such type of nuclei. And the energy separation between two successive levels is of the order of kilo electron volt. Did you get what I'm trying to say? When you are discussing that nuclear any level, the order of separation is actually of the order of mega electron volt. However, for this type of nuclei, these are the level exist with even spin and even parity, and the energy separation between levels, two successive levels, that is of the order of kilo electron volt. And that separation is going to increase when you are going to higher spin level. I mean, when separation between 0 to 2 state, if you are going 2 to 4, I mean 4 to 2, this separation will be larger as compared to this. This separation will be larger as compared to this. But all this separation is actually of the order of kilo electron volt. If I talk about tungsten atomic number is how much? 74, mass number 174. So I can see that both proton number and neutron number both are actually even. For tungsten, the separation between ground state and first excited state. So see, this is your ground state, this is your first excited state, this is your second excited state, and so on, right? So for this nuclei, the separation between ground state and first excited state, that is 100 kilo electron volt. However, this separation is going to increase if you are going from 2 to 4, that will be higher as compared to this. Then 4 to 2, that will be higher as compared to 4 to 2. Sorry, 6 to 4, that will be higher as compared to 4 to 2, and so on. Okay. And also, if I talk about that quadrupole moment for when you have a mass number between 150 to 200. For such nuclei, that quadrupole moment is actually, quadrupole moment means electrical quadrupole moment, that is large negative value. And for this nuclei, the quadrupole moment or electrical quadrupole moment is actually having a large positive value. What is the meaning of this? Large negative value and large positive value. What is the meaning of this? Can anyone tell me what is the meaning of this? Large negative value and a large positive value. It means their shape is not actually spherical. है ना? Sphere के लिए quadrupole moment कितना होना चाहिए? Spherical shape के लिए. For spherical shape, quadrupole moment will be 0, right? If you remember the definition of quadrupole moment, it was like 2 by 5, then you have z into b square minus a square, right? So for spherical shape, that b is actually equals to a. It means for spherical shape nucleus quadrupole moment is 0. But when you have quadrupole moment is large negative value, it means the shape is oblate shape. And quadrupole moment large positive means shape is actually not spherical but it is prolate. What I can say from this discussion that such nuclei is having deformed shape. It's not actually perfectly sphere, but such nuclei is having some deformed shape. Then Bohr said that this deformed shape is a consequence of rotation of such nuclei. है ना? जैसे सपोज मान लो आप एक लिक्विड ड्रॉप को सपोज मान लो आपने ली हो और उसको अगर रोटेट कराओगे, है ना? सपोज मान लो आपका एक spherical liquid drop है. If you rotate it due to centripetal force, that shape will be deformed, right? Due to centripetal force, that shape will be deformed from spherical symmetry. So Bohr said that deformed shape of such nuclei is arising because of rotation of such nuclei. Rotation of such nuclei. And if the this nuclei is having rotation, then rotational energy will be how much? If this nuclei is having or possessing that rotation, then the rotational energy will be how much? So that rotational, that deformed shape is arising because of rotation, and that rotational energy that I can write E equals to L square by twice I, right? Where I is the moment of inertia and L is the orbital quantum number. Now we know that L square, when L square operate on psi, what will be the energy what will be the eigenvalue of L square if it operate on psi? It will be like L into L plus on H cross square, right? And then you have psi. It means the rotational energy of such nuclei, the deformed shape is arising because of rotation, then it will have rotational energy, and that will be L into L plus on H cross square by twice I, where I is the moment of inertia and L is the rotational quantum number. Okay. And better you will use that symbol here, L subscript. Okay, na? And L, what are the possible values of L? Anyone can tell me? क्या का possible values होती है L का? It can take values like 0, then 1, then 2, and 3, and so on. These are the possible values of L, right? Now I'll write that L values, then corresponding energy EL, and the spin parity of this nuclei. So least possible value of L, that is 0, and corresponding energy, I can see if you substitute 0 here, it will be 0. And not only the JP value here. So I know that parity, how will define that parity? Parity कैसे define करोगे? Minus on the power क्या हो जाएगा?
L.
Sorry, L?
L+1.
I'm not here. 1 minute. Can't hear. Now can you repeat what you're saying? Am I audible?
-1 to the power of L+1.
L plus 1, why L plus 1? Why A minus 1 की power L plus 1?
-1 raised per L.
Exactly, minus 1 की power L. Minus 1 की power L. Okay. So now for
Sir.
this, हाँ जी.
Sir, yes, sir.
Now for this set, what is the spin parity? L की वैल्यू 0 है ना? तो यहाँ पे क्या हो जाएगा आपका? That will be positive, right? Parity will be positive. What will be the value of J? J will be this number. So here you will have 0, which if you substitute L equals to 0 here, that will give you positive parity. So this will be your ground state. This is ground state. This is your ground state. Then if you take L equals to on, what will be the EL value?
Sir,
Ah,
the J is here. What? L?
is your L. Why J equals to L here? J क्या है आपका?
So we were taking in. Okay,
Saying J equals to what? I mean summation of L plus S.
L plus 1 by, yes, plus 1
Plus
by
S
2.
or L minus S. But why I'm taking only L? You people tell me. Why I'm taking
Yeah.
L? Can anyone tell me why I'm taking L? I'm ignoring S part. Why? Any clue? See, this kind of question is really interesting.
Nuclear spin, whole spin of nuclei.
When you
not
have even
one.
combination, when you have a even combination, what we are discussing, you have a even combination. When even combination, this all protons, suppose this is your proton and this is your neutron, all protons are paired, all neutrons are also paired. तो paired के लिए S का वैल्यू कितना होनी चाहिए? सॉरी, S का वैल्यू कितना होनी चाहिए paired के लिए? 0 होना चाहिए ना, जब आपका paired है ना?
Okay,
If you have paired combination, then net S will be 0. है ना? According to Hund's rule, है ना? Please go through Hund's rule, then you will get that proper answer. In atomic physics, you learn. When you have a paired means there will be net spin 0. So that's why S is 0, so J will be equals to L here. Now is this clear? Now if you take L equals to on, what will be the value of EL? कितना आ जाएगा EL का value? So if you substitute L equals to on here, that will give you 1 into 2 h cross square by 2. That is nothing but h cross square by I. That is nothing but h cross square by I, right? And what will be the spin parity? You people tell me. कितना आ जाएगा?
1 odd.
On with negative.
Minus.
But this is not possible. Because you have noticed that experimentally क्या क्या है आपका? First of all, you have a 0 plus. Then second is your 2 plus. है ना? So although this, I mean, the energy values like this is your ground state energy. This is your ground state energy that's matching with, spin and parity. That is matching with spin and parity. In the first excited state, that energy is h cross square by I. That is higher than ground state. But this state is not possible because not matching with this level. According to this level, the parity should be even. Here it is odd. Also spin is on. So this state is not possible. Next value of L, that is 2. Next value of L, that is 2. And what is the possible value of EL here? That will be 2 into 3. That is nothing but 6 h cross square by 2I. That is nothing but 3 h cross square by I. But this state will have J value that is equals to L. And of course, when L is even here, that parity will also be even. But that is perfectly fine. Okay. So this is the ground state set. L, energy, and spin parity. Next, L is not possible, so I cannot take that first excited energy this much. Rather, I have to take first excited energy this much because it is violating this. So you have to keep in mind that ground state energy is this much, first excited is this much. Again, if you take L equals to 3, that will give you 3 into 4, 12. It means 6
h square.
6 h cross square by I, right? But problem with, again, this is 3 minus, that is not possible. Okay, so I cannot take second excitation energy this much. Rather, what I have to do, again, I have to take even value of L, and that will give you how much? 10 h cross square by I. And that state will be what? That will be your 4 plus. And this is perfectly fine. So these are the, I mean, you understood that what possible values you can take, because few of the state, I mean, alternative states are not possible because that is violating that spin and parity. So understood at least that why you are taking J equals to L, because your that is actually observable for even combination, and for even all nucleons are paired. When you have a paired nucleons, you will have spin 0. Now if I ask you what is the separation between 0 plus and next possible state, that is 2 plus, how much will be the separation? Delta E कितना आ जाएगा यहाँ पे? Separation between कितना आ जाएगा? That will be h cross square by I, right? You can write like this: separation between 0 plus and 2 plus, that is nothing but E2 minus E0. E2 minus E0 कितना आ जाएगा? That will be
3h square by I.
3h cross square by I आएगा. 2 into 3, that is 6. 3h cross square by I. Very good. Next, that separation between 2 plus and 4 plus. So this 0 corresponding to ground state, this is your first excited state, this is your second excited state. So separation between first excited state and ground state, that is 3h cross square by I. Second excited state and first excited state, that separation is how much? So that you have to write E4 minus E2. And E4 is how much?
7h square by I.
10h cross square by I minus
3.
3h cross square by I, right?
Yes, 7.
And that will be how much?
7.
7h cross square by I. Okay. Again, the separation between 4 plus and 6 plus कितना आ जाएगा? So that will be E6 minus E4. ठीक है ना?
21h square.
6 means how much?
21.
21, right? 20 on h cross square by I minus 10, right? 10 h cross square by I. And that will give you how much? 11 h cross square by I. But why I am doing this? Anyone has idea? क्यों मैं कर रहा हूँ यहाँ पे? I can see that separation between two successive level फर्स्ट एक्साइटेड और ग्राउंड स्टेट के बीच में कितना है, दिस मच है ना. सेकंड एक्साइटेड स्टेट और फर्स्ट एक्साइटेड स्टेट के बीच में कितना है, 7h/i.
It is increasing.
हाँ, it is increasing with increasing that value of spin. ठीक है. So I can see here.
Sir,
Yes.
why this odd parity is not possible there?
Odd parity is not possible. This is why. You tell me. Because this is, I mean, initially, I mean, that is experimentally observed spectra, and these are the possible levels with spin parity that is experimentally observed. Okay, so that's, I mean, you have experimental data, then you are
Yes, sir,
performing that. I mean, you are going to discuss about that theory, है ना? So why that odd parity is not possible? Because that state is not matching with that experimental data. That's why we are ignoring that. ठीक है. ठीक है. Or you can say in other words that I mean nature like symmetry. You can explain in other way. In interview, someone asks you why odd parity is not possible, because every system in the nature likes symmetry. Every system in the nature likes symmetry. Actually, nature or universe likes symmetry. So when you have a odd parity, there's some kind of absence of reflection symmetry in the system. When you have even parity, it means there is a presence of reflection symmetry in your system. Okay, so system or nature actually like that symmetry. You know? So that you may give that answer like this. ठीक है. So odd parity का मतलब क्या हुआ है आपका, बताओ. That such system do not have reflection symmetry, because parity actually defines that reflection symmetry. What parity define? Parity define that reflection symmetry of your system. When you have an odd parity, if I give a simple example, then it will be more clear. Na? But let me tell you again that this, I mean, why they are concluding, because they have experimental data in their hand. And since that the parity and spin is not matching, that's why they are ignoring. But someone asked that philosophy or I mean theoretical reason behind that. You may say that when you have a system like odd parity, that is not actually that is actually violating that reflection symmetry. Every system in the nature likes symmetry. You have odd parity, it means it is violating reflection symmetry. If I give that example of wave function, suppose you have a wave function like this, 0 a minus a, and if you have a wave function like this, sorry, 0 a minus a, which one will have reflection symmetry? किसका reflection symmetry है बताओ?
First one.
First one.
First one is having reflection symmetry. Second one is do not having any reflection, right?
So, but it is symmetric about origin.
Parity is defining that reflection symmetry. I'm not saying that reflection symmetry about the origin. So if you take that, I mean mirror image of that, is it a mirror image of this?
No, sir.
No. Okay. So you can give that example, I mean explanation like that when you have a odd parity, that is not actually, I mean, that is not defining that reflection symmetry of a system. I mean, you actually, what is happening? Your shape is changing, right? Shape is changing, like you have a prolet shape or oblate shape. But still, when you have a prolet shape or oblate shape of your nucleus, still that system is having reflection symmetry. You may check, you may go through, and you can check that still when you have a deformed shape nucleus, still that nucleus is having reflection symmetry. And when you are taking that odd parity, it will violate that reflection symmetry. So we cannot take. I think you got that answer. If you want more explanation, you may ask. We can go on problem because it's a really very simple model, but based on this you will get answer. I mean, you will get question in CSIR net. I think 3-4 times they ask that question from here, and that question is, I mean, very simple. What used to happen in nuclear physics? CSIR net used to ask question from net physics. I mean, from nuclear physics. That question is actually having lengthy, I mean, solution. But in this model, that model is so simple. Just you have to have idea which one will be, which are the possible state, which are the states that is possible. That much idea you need to have to solve that problem, especially for CSR. ठीक है ना? तो ज्यादा लेंथी कैलकुलेशन नहीं है, थोड़ा सा लॉजिक होना चाहिए, आपको होना पड़ेगा कि कौन सा स्टेट पॉसिबल है ना? और यहाँ से क्वेश्चन भी आते हैं, है ना? सिंपलेस्ट न्यूक्लियर फिजिक्स में थोड़ा लेंथी क्वेश्चन आते हैं, बट यहाँ से आपका क्वेश्चन बहुत इजीली हो जाता है. So first question, if I discuss, you have a nucleus uranium 92 to 38. This is your nucleus, and for this nucleus, first excited state का energy given है. For this nucleus, first excited state, है ना? It is mentioned in that question that this nucleus is having rotational spectra, and the energy of the first excited state is equals to 45 kilo electron volt. So whenever they are giving that energy in the form of kilo electron volt, it means this corresponds to what? You have a rotational level. And what they have asked, what is the second excited energy? Second excited state energy is how much? That is they ask. So very simple. It is mentioned that this nucleus is performing rotational spectra, and the energy of the first excited state is 45 kilo electron volt. What will be the second excited state energy? This is the question. Okay, and you can see that this nucleus is having even combination 92. That is the proton number. Even you can get that
146.
electron number also. How much? So
146.
450.
450 is the answer.
So first excited state means E2, right?
So
And
if I,
second will be
solve
E4.
that, it means
E4 will be 10 times.
Actually, 3h cross square by I.
Yes, sir.
That is given. That is 45, right?
Yes, sir.
And E4, that is actually asked, and that will be how much?
10 h cut square upon
3h cross square by I,
150.
and that is we don't know.
Yes, sir.
Now if I divide E4 by E2, that will be how much? E4 by E2, that if I divide, that will be 10 by 3. Okay, it means E4 will be how much? E4 will be E2 into 10 by 3. And E2 is how much? E2 is 45 into 10 by 3. Okay, and of course that unit will be kilo electron volt. So we cancel, it will be 50, sorry, on 15, it will be on 50 kilo electron volt. Just you have to have idea that what are the possible values of J here. Okay, that much. Only even values of J are possible. First 0, that is ground state. 2, that is first excited state. 4, that is second excited state, and so on. Let me do another problem, then we'll
So in previous question, it is given that it is a rotational model.
exactly. It will be
Okay,
mentioned.
sir.
It will be mentioned there. Second problem you can write, then it will be clear. A permanently deformed even nuclei, a permanently deformed even nuclei with Jp equals to 2 plus. A permanently deformed even nuclei with Jp equals to 2 plus has rotational energy 93 kiloelectron volt. A permanently deformed even nuclei with Jp equals to 2 plus has rotational energy of 93 kiloelectron volt. Full stop. Calculate the energy of the next allowed state. Calculate the energy of the next allowed state.
सर हैश के बाद वाला रिपीट करना प्लीज.
Rotational a
D10,
permanently
sir.
deformed even nuclei with Jp equals to 2 plus has rotational energy 93 kiloelectron volt. Calculate the energy of the next allowed state.
310, sir. Answer 310 kilo electron volt.
Exactly.
310.
It means again, so 2 plus का energy given है ना? कितना given है? 930. It means they are asking about, so E2 is given. E2 is how much? 93, right? Just we have, and they are asking about that next allowed state, that is E4. So just we have seen that E4 by E2, है ना? अभी हम लोगों ने किया था. That is how much? 10 by 3. It means E4 will be how much? E2 into 10 by 3. And E2 is 93 into 10 by 3. And of course, unit will be kiloelectron volt. And if you solve it, you will get E4, that will be 3 on 10 kiloelectron volt. Okay, now? So you can see that the calculation is very simple, but this will be 5 marks question. Can you imagine? And many students not used to get answer. Why they are making? They used to make mistake here. They used to take that when they are giving that j equals this value, next state allowed state, they used to take 3. They used to make such kind of mistake. Okay. Okay. Now next part that we are going to discuss, that is your deuteron problem, and this is also really important. Deuteron problem. What is deuteron?
H13.
Sorry,
H13.
on 3. Anyone more? What is deuteron?
H1.
Excuse me. Deuteron means what? On H2, right? On H2, this is your deuteron. Or I can say, suppose this is the nucleus, and if you are talking about deuteron, it will have NP. So this is a basically 2 nucleon system. 2 nucleon stable system. Why I'm taking stable system? 2 nucleon system can be like NN, PP, or NP. These are not stable. This is the NN 2 nucleon system, मतलब 2 nucleons है. ये भी stable नहीं है, PP भी stable नहीं है. But this is the stable. So I can say deuteron is a 2 nucleon nucleus, or 2 nucleons stable nucleus. 2 nucleons stable nucleus. Why? Because this is not possible. This is not stable. This is also not stable. So your 2 nucleons only 2 nucleons stable nucleus, that is your deuteron. Because NN, that is also not possible. PP, that is also not possible, or not stable there. Now, if I talk about few properties of deuteron, properties of
So can you just repeat the last statement, sir? My network was a little bit not working.
what repeat? I have to repeat. Tell me.
So this neutron, you have told that
What I'm
it will not be.
what I'm saying, deuteron is two nucleons, only two nucleon stable system, because two nucleon stable system means two nucleon system means what? This is your two nucleon system. This is a nucleus in which there are two nucleons present. This is also two nucleon system, and this is also two nucleon system. है ना, जहाँ पे दो प्रोटॉन प्रोटॉन है, यहाँ पे दो न्यूट्रॉन्स है, यहाँ पे एक न्यूट्रॉन एक प्रोटॉन है. This is not stable, this is not stable, but deuteron is stable. What I'm saying, that deuteron is only two nucleons stable nucleus. Because why? Because this is not stable, this is also not stable. Few properties of deuteron. Can you tell me one by one? Suppose the binding energy of deuteron. What is the binding energy of deuteron? कितना होती है binding energy? बताओ. Binding energy around 2.2 electron volt. So binding energy per nucleon कितना हो जाएगा? Binding energy per nucleon कितना हो जाएगा? That will be
1.1.
1.1. What's the meaning of this? What is the meaning?
Loosely bound.
Loosely bound, exactly. The next properties. Electrical quadrupole moment. Electrical quadrupole moment. Q. That is 0.28 femtometer square. What is the meaning of this? What is the meaning of this? That deuteron is having quadrupole moment 0.28 femtometer per square. का मतलब क्या है? Tell me the meaning of this.
It's positive and solid.
Exactly. So what I can say, that deuteron, that nucleus, the shape of deuteron is not actually perfectly sphere, but it will be like roulette shape. The shape of nucleus, the nucleus shape of deuteron is not sphere, but it will be roulette shape. ठीक है. Next property, that is the spin parity. Spin parity of deuteron is on plus. The spin parity of deuteron is on plus. Can you prove any on? That spin parity of deuteron is on plus. Prove कर सकते हो इसको? Can anyone prove that spin parity of deuteron is on plus? So very simple, because you have a on deuteron is nothing but 1s2 nucleus, right? On proton and on neutron is there. What I can say here, we will have Z equals to on. It means that filling will be 1s on is half on, and also neutron is how many? On. So I will fill like this. It means JP is how much? That will be JP कितना है? हाफ है. LP कितना है? 0 है. JN कितना है? That is half. LN कितना है? That is 0. Right? JP half, LP 0, JN half, LN 0. Right? ठीक है ना? क्या ये समझ में आया ना? आप लोगों को करना चाहिए था ये. So now if you sum JP, sorry, JN plus JP, whatever that order you can take, LP plus LN, कितना आ जाएगा ये? How much you'll get here? That will be your
Sir, it is one odd.
on odd, right? it means net J will be how much? That will be mod of JP plus JN, right? And that will be on. And of course parity कितना जाएगा?
-1 to the power N3 plus
Exactly. So -1 की power LP plus LN. And that will be how much? कितना आ जाएगा?
Even parity आएगा sir.
Even
-1 to the power 0.
positive. So, right? It means that will be possible. Even what I said that first जो point लिखा था आपको, आप लोग क्या लिखवाया था वहां पे? बाइंडिंग एनर्जी, टोटल बाइंडिंग एनर्जी, वो भी आप कैलकुलेट कर सकते हो. कैसे कैलकुलेट करोगे वो? आप लोगों ने कैलकुलेट किया ना, आप लोगों ने लिखा ना बाइंडिंग एनर्जी कितना लिखे हो? 2.2 MeV ना. That also you can calculate. From here you will calculate. You have a system on H2. You have a system, right? So first, if you calculate the mass defect क्या हो जाएगी? MP plus Mn minus ठीक है. Or I can write here that MH plus Mn minus atomic mass of on H2. ठीक है ना? And this mass will be known. MH you know, Mn you know. Atomic mass you can measure. That will be provided. If you calculate from here, right? Did you get what I'm saying? This mass you know, this mass you know, and that is also known. You have an atom, you can measure that mass of this atom, neutron atom. Okay, so you can calculate delta M, and if you multiply by C square, you will get binding energy. Okay.
So,
Haji.
so when we were doing that binding energy, we stated that this is loosely bound.
Yes.
So मुझे नहीं आ रहा mind में.
Loosely bound means what? I mean, binding energy between what you are calculating? You have a bound system, right? I mean, binding energy between what? Binding energy between, you have a 2 nucleon system, binding energy between proton and neutron. ठीक है ना? वहां पे तो 2 न्यूक्लियन है ना, दोनों न्यूक्लियन है ना? And this nucleon, I mean, you are calculating binding energy per nucleon, you are getting value on mega electron volt. Okay, so they are actually bound within what? They are bound to nucleus. You have a neutron and you have a proton. Loosely bound means what? If you provide that energy, if you provide this nucleus to energy 2.2 mega electron volt, then they will be separated. है ना? अगर सपोज मान लो बाइंडिंग एनर्जी ज्यादा होता है, यहाँ पे सपोज मान लो आपका 16 MeV होता है ना, अब इसको सेपरेट करने के लिए कितना एनर्जी चाहिए होता आपको? एटलीस्ट 16 मेगा इलेक्ट्रॉन वोल्ट आपको चाहिए होता. तो लूजली बाउंड मतलब यहाँ पे आपको जो ये तो बाउंड सिस्टम है. फर्स्ट ऑफ ऑल देयर बाउंड सिस्टम, बाउंड मींस दे आर एक्चुअली अट्रैक्टिंग, है ना? लूजली बाउंड मतलब आपको कितना एनर्जी देना पड़ेगा? न्यूट्रॉन प्रोटॉन जो न्यूट्रॉन सिस्टम है इसको अगर 2.2 मेगा इलेक्ट्रॉन वोल्ट एनर्जी बाहर से सप्लाई करोगे, दे विल बी सेपरेटेड, है ना? अगर बाइंडिंग एनर्जी ज्यादा होता, इसका मतलब that system is actually strongly bound. Why? Because you have to supply more energy from external source to separate them. है ना?
Sir, मैं पूछना चाह रही हूँ कि with which energy range we will say that the system is loosely bound. मतलब there is some like 2.2. You said that this is loosely bound, and
yes, we have discussed this.
after which
Binding energy per nucleon car. Binding energy per nucleon car, we have discussed this thing. When you have a mass number less than 130, less than 30 or above 120, है ना? उनका जो बाइंडिंग एनर्जी है that is less than somehow 7 mega electron volt.
yes, yes.
So they are basically loosely bound.
Okay.
जैसे मान लो सपोज मान लो आपके कमरा पे किसी ने बांध दिया, है ना? ना, थोड़ा सा फोर्स लगा के आप निकाल सकते हो। इसका मतलब क्या है, आप बंधे हो तो हुए हो, बट थोड़ा सा एक आपको एनर्जी मिल जाए तो फिर आप निकाल सकते हो। और बाइंडिंग एनर्जी ज्यादा है, मतलब आपको बहुत ये करके बांध दिया है ना, आप निकल ही नहीं सकते हो। इसका मतलब क्या है कि आप स्ट्रांगली बाउंड हो।
Okay, sir.
So you can calculate. What I'm trying to say from here, that you can calculate the binding energy of deuteron system also, because mass of hydrogen is known, mass of neutron is known. That is also easily you can calculate. That they will provide you data also. So you can calculate this binding energy also. Spin parity you can calculate. ठीक है, मैं इसीलिए बोल रहा हूँ क्योंकि आगे आपको कैलकुलेट करने के लिए भी बोले ना, या आपको डाटा याद नहीं है ना, तो थोड़ा सा लॉजिक लगा के आप निकाल सकते हो। ऐसा तो नहीं है कि हमेशा इतना सारी चीज आपको दिमाग में आएगा, आप लॉजिक लगा के निकाल सकते हो इसको, है ना। अगर भूल गया तो इतना सारे डाटा तो याद नहीं रहेगा ना, बहुत सारे डाटा है आपके पास, तो यू कैन फाइंड दैट आल्सो। नेक्स्ट यू हैव ए ग्राउंड स्टेट ऑफ ड्यूट्रॉन। ग्राउंड स्टेट ऑफ ड्यूट्रॉन, ground state of neutron, and that is 3s on and 3d on, है ना। Can anyone calculate, can prove that ground state of neutron is 3s on and 3d on? So first of all, it cannot be 100% 3s on. That it is 96% contribution of 3s on, and 3d on is having only 4%. But what I'm saying that it cannot be 100% of 3s on. Can anyone tell me what is the reason behind that? कि क्यों आप 3s on 100% हो नहीं सकता है? There should be some mixing of 3d on also, but 3p p state is not possible here. एक एक करके बोलो कि 3s on क्यों नहीं हो सकता 100%? क्यों नहीं हो सकता है? देखो 3s on इसीलिए नहीं हो सकता है क्योंकि आपने जस्ट अभी कैलकुलेट किया था अपना आपका क्वाड्रुपल मूवमेंट, आपने अभी देखा था डाटा क्वाड्रुपल मूवमेंट कितना है 0.28 फेमटोमीटर स्क्वायर। इसका मतलब क्या है कि the shape of the nucleus cannot be spherical. When you are taking 3s on means s orbital, and s orbital is having spherical shape, है ना, so that nucleus is not perfectly sphere, so there should be some mixing of non-spherical orbital also, and that is your d orbital. But why not p orbital here? Why not p orbital? P orbital is not possible here because of parity, because when you are taking p orbital means L equals to 1, and that will give your odd parity, but you have seen that parity of deuteron is even. On plus means even parity. That's why that p state is not possible. You can check. Suppose you have a L वैल्यू मिनिमम कितना पॉसिबल है? L का मिनिमम कितना पॉसिबल वैल्यू है? 0. You have a 2 nucleon system, so S net S will be how much? क्या हो सकता है? Deuteron is your 2 nucleon system, so net spin will be mod of sp plus sn to mod of sp minus sn. स्पिन कितना होता है प्रोटॉन और न्यूट्रॉन का, दोनों का हाफ हाफ होती है, तो ऑन हाफ प्लस हाफ दैट विल गिव यू ऑन, एंड हाफ माइनस हाफ दैट विल गिव यू 0. So I'll take different possible value of L and S. So first of all, when L is 0, that is the minimum possible value, and corresponding S I'll take 0, and that will give J कितना provide करेगा यहाँ पे?
0.
0 provide करेगा, and 0 J is not possible because you have just calculated that spin of deuteron is how much? 1. हमने अभी कैलकुलेट किया ना ड्यूट्रॉन का स्पिन कितना है?
Yes, sir. 1.
नेक्स्ट कॉम्बिनेशन क्या है? इफ यू टेक S equals to 1, if you take S equals to 1, what will be the value of J?
1.
On. What will be the parity for such combination? आपका L का वैल्यू 0 है, तो parity कितना हो जाएगा?
1.
And that is perfectly fine. Now in atomic physics, how you used to write the term? You have a 2s plus on Lj, right? इस कॉम्बिनेशन के लिए 2s plus 1 का वैल्यू कितना हो जाएगा?
3.
3 हो जाएगा. L का वैल्यू 0 तो ऑब्वियसली S J का वैल्यू कितना है ऑन है, सो दैट इज द पॉसिबल 3s ऑन। तो एक तो ये कॉम्बिनेशन पॉसिबल है। नेक्स्ट L का वैल्यू क्या पॉसिबल है? नेक्स्ट L का वैल्यू if you take L equals to 1, there is the next possible value of L. Again, if you take S equals to 0, S equals to 0 and on, that will provide क्या क्या प्रोवाइड करेगा यहाँ पे स्टेट, क्या क्या स्टेट प्रोवाइड करेगा? लेट अस टेक वन बाय वन। व्हेन यू आर टेकिंग S equals to 0, J क्या हो जाएगा? ऑन हो जाएगा, बट पैरिटी क्या हो जाएगा? ऑड हो जाएगा, राइट? इट मींस दैट इज नॉट पॉसिबल। If you take S equals to on with L equals to on, and that will provide you J equals to 2 on 0 with odd parity. That is also not possible because odd parity is not possible. So all L equals to on state is not possible because of parity. Neutron is having even parity. But if you take next L, that is L equals to 2, and you have a S equals to 0, and that will give you J कितना देगा आपका? 2 देगा, right? With even parity, that is also not possible. But if you take next L, that is 2 with S equals to on, ठीक है ना? यहाँ पे J क्या मिलेगा आपका? 2 on 0, right? With all 2 on 0 or 3 to 1, 3 to 1
3 to 1. J equals to L plus S.
with even parity. But these are not possible because nuclear spin is not 3 or 2 or on. Sorry, not 3 or 2, but it is on. This is possible. So for such spin, what will be the term? क्या आ जाएगा यहाँ पे? 2s plus on, again that will be 3. L का वैल्यू कितना है? 2, that will give you D, and J का वैल्यू on. So these are the state, ground state that is possible for deuteron, 3s on and 3d on. ठीक है ना? And next property of deuteron is what? Magnetic moment. Magnetic moment. Magnetic moment of deuteron. Now if I ask you what deuteron is having composition like proton and neutron, right? Deuteron के पास क्या है? एक proton है और एक neutron है. एक प्रोटॉन है, एक न्यूट्रॉन है. मैग्नेटिक मोमेंट प्रोटॉन का कितना है? एक प्रोटॉन का मैग्नेटिक मोमेंट कितना होती है? Can anyone tell me कितना होती है मैग्नेटिक मोमेंट ऑफ ए प्रोटॉन? That is 2.79 μn, right? Μn means nuclear magnetron. And then you have a magnetic moment of a neutron is how much? That is minus 1.9 on 3 μn. है ना? But if you see that magnetic moment, actual magnetic moment of a deuteron is how much? कितना होती है? Can anyone has idea? कितना होती है? That is 0.85 μn. अगर आप मैग्नेटिक मोमेंट ऑफ प्रोटॉन एंड मैग्नेटिक मोमेंट ऑफ न्यूट्रॉन कैलकुलेट करोगे कितना आएगा? If you sum this, that will be around 0.88. ठीक है ना? Although deuteron is having only a proton and neutron, but if you sum the magnetic moment of proton and neutron, that will be 0.88. But experimental value or actual value of magnetic moment of a deuteron is 0.85. So what I can say that magnetic moment of a proton plus magnetic moment of a neutron minus magnetic moment of a deuteron, that is equals to non-zero. So it means that charge distribution inside deuteron is not spherically symmetric. It means charge distribution inside deuteron is not spherically symmetric. So measured value of magnetic moment is a magnetic moment of deuteron is actually different from its composition, है ना. इनका composition का जो magnetic moment है ना, some of this actually not equals to the actual value of magnetic moment of a deuteron. Charge distribution inside magnetic moment is not spherically symmetric. So I'll end here, because now next part we have to solve the deuteron problem to find out the potential depth of nucleus of a deuteron. Okay, so tomorrow we'll solve. It will be lengthy. Let's stop here. Okay then.